In this video, I'm going to show you how to draw Lewis structures. If you would like to review covalent bonding and some of the language and words around Lewis structures, you can view the video on the introduction to covalent bonding. So Lewis structures show the different atoms, how they're arranged, and the types of bonds and lone pairs that are present. And on this slide, there's a few things that will be true for us as we work through Lewis structures. So the first thing is that Lewis structures only represent valence electrons. Remember, valence electrons are the electrons in the outermost energy level, and for the main group elements, they are easily determined by looking at the number that's in front of the letter A. Now we're going to be drawing Lewis structures for compounds that follow the octet rule. And the octet rule says, when referring to covalent bonds, that elements will share valence electrons to have the electron configuration of the noble gas closest to them. And so since all of the noble gases except helium have 8 valence electrons, what the octet rule says is that the other atoms will try to have 8 valence electrons by sharing. So when we draw our Lewis structures, we're going to end up where every main group element has 8 electrons around it, except for hydrogen, because hydrogen can only have 2 electrons. If you refer to a periodic table and think about electron configurations, we know in period 1 that only contains hydrogen and helium, there is only an s orbital, and the maximum electrons are 2. So for that first period, hydrogen and helium, 2 would be considered a full valence shell. So again, to summarize quickly, just keep in mind we're only going to be thinking about valence electrons. We're going to try to give every main group element, except for hydrogen, 8 electrons. And hydrogens will only be able to have 2. So that means they will only be able to have a single bond. So let's get into the process of drawing Lewis structures. And I have some steps written here. And the way I approach Lewis structures is very methodical. As you get better at it, you might not think about it exactly in the steps, but this is a really good place to start. And the method that I'm using, I did not make up, but I like it because if you follow this method, even when you go to if you are going to the next level chemistry, where you will have Lewis structures that have exceptions to the octet rule, following this method, you will be able to determine when there are exceptions. So I think it's a really good place to start. So looking at steps 1 and 2 right here, it's not required that you do this in the order, but we always have to start with these 2 steps. And I'm going to draw a Lewis structure along with the steps, and I am going to do H2S to start with. So step 1 says arrange the atoms next to each other that you think are bonded together. Place hydrogens and the halogens on the periphery since they can only form one bond. So let's just make sure we all know what periphery means. These are going to be the atoms that are outside of the central atom. So in our class, we are looking at simple molecules that have usually one central atom. If they have more than one central atom, it will be indicated to us. They'll give us a little more detail. But we'll be looking at ones that have one central atom. So a central atom is the one that goes in the center. And then the periphery would be the atoms that are outside or around the center atom. Okay, so normally when we look at a structure, the first atom in the formula is going to be the central atom. And I will do some that are like that, but for right now, I look at H2S. And so normally I would think, hydrogen would be the center atom. But hydrogen can never be the center atom because it can only have one bond. And so you can't be in the middle of something and have only one bond. So if hydrogen is written first, then you would go to the next element to put it in the middle. So what step 1 says is arrange them. So I'm going to put sulfur in the middle, and I'm going to put 2 hydrogens around it. I tend to start like 180 degrees in a line, and then I'll go up and down like I was making a T or a cross. Lewis structures don't have to be drawn to show shape. So if you, for example, put the H's like that next to each other, or let's say you did it like this, all of that would be a fine place to start as long as sulfur is in the middle. Okay, so that would be step 1. Check, we arranged them. Step 2, it says count the valence electrons. Use this many electrons in the structure. And that's an important idea. So we're going to be counting up our valence electrons, and that is going to be how many dots or electrons we can use. And just as a reminder here, which we've been doing in previous videos and in class, is for main group elements, we will just look at the periodic table because the number of valence electrons is the same as the group number. So if you have a periodic table next to you, it might be helpful for this video. So I would look, I'm just going to write, we're going to calculate the valence electrons. And so when I do this, I kind of make a little chart for myself. I'm not going to use dots because that looks like valence electrons. Sorry. So I have hydrogen and I have sulfur. Now you have to look at the formula because you have to take into account how many you have. So hydrogen has 1 valence electron, but my formula has 2 hydrogens, which I can determine by the subscript 2. So that means the hydrogens bring 2 electrons, and then sulfur is in group 6A, so it has 6 valence electrons, and there's only 1 sulfur in my formula, so that would bring 6 electrons. So then adding these 2 together, I get an 8 electrons total. Now this is what step 2 is asking us to do. And this, I always call it the magic number because we have to use 8 electrons. Okay, so it can't be more, it can't be less for this Lewis structure to be correct. So it's important that you understand, 1, how to calculate the valence electrons, because if you get that number incorrect, then your answer will be incorrect. And then 2, when you're actually doing the structure, you want to make sure that you use that number. So I always recommend at the end, count and make sure that you have used the correct number. All right, so that would be step 2. Check. Now we'll go to step 3, and there's different things here. Let's just read through it, and then we'll go through it again. So it says, step 3 is all about arranging the electrons. So now we know we have 8 and arrange. And so this is what I do first. Place 1 bond, 2 electrons between every 2 atoms. Now, although some structures do have rings and all sorts of different things, ours really, when we're learning, as we introduce Lewis structures, our bonds are all going to be going back to the central atom. Okay, so we're going to place 1 bond, and then just some things to consider. It says main group elements get no more than 8, and hydrogen gets no more than 2. Okay, so let's place the bonds. So in my case, I would place a bond between hydrogen and sulfur on this side and on this side. Okay, so that would be placing, that's what it means, place one bond. Then it says, after we did that, use all remaining electrons to fill octets with lone pairs. And here's something that's very important. You begin with the atoms on the outside or the periphery. So you're basically what you're doing is taking any leftover electrons and making sure all the atoms have 8. And when you do this, you start with the outside atoms and then you finish by looking at the central atom. So fix the outside atoms first, then the central atom. So how many electrons do I have remaining? Well, I made 2 bonds, so just to write it down, I have 8 electrons total, and I used 4 electrons. I hit a button. How I used 4 electrons is there's 2, 4. Remember, each covalent bond is 2 electrons, so that would be 2 here and 4 there. So I used 4 electrons. So 4 electrons used. So I have 4 electrons that remain. And you may want to write things like this down, or you can do it in your mind. So 4 electrons remaining. I would first look at my exterior atoms, the hydrogens, but they're satisfied because hydrogen can only have a single bond. So I'm not going to place any electrons there. And so then with the remaining 4, I put them on sulfur. So now if I look, sulfur has 2, 4, 6, 8. So it has 8 electrons around it, and I used total of 8 electrons. So this right here, I'm getting rid of the highlighting, that right there would be the correct Lewis structure for H2S. You see here it says if all the valence electrons are used and an atom still does not have 8, proceed to step 4. Okay, so I have step 4 coming up, but I want to do a few examples where we use all of our valence electrons and everybody has 8. So I want to do a couple more examples. So in this example, again, let's think about it. Let's just look at the steps again, and then we're going to do 2 more practice problems. So step 1 is you arrange the atoms how you think they're going to be bonded together. Remember, normally when we get our formulas for class, the first element in the formula will be the one in the center, and the others will be on the periphery. That is different, like in our example, if hydrogen is written first, because hydrogen cannot be in the center. So then go to the next element and put it in the center. After you have the arrangement, go to step 2 and you add up all the valence electrons using the periodic table to see how many electrons are going to be placed on your structure. Then step 3 is you're going to arrange the electrons around your structure. Start by drawing single bonds that connect the periphery atoms to the central one. Each single bond represents 2 electrons. Count up how many electrons it takes to do the single bonds, and then you'll have some left over usually, and then you place the leftover ones on the elements so that everyone has 8. You'll start by placing on the periphery and then the center. In our example, the periphery was hydrogen, so it was already satisfied, or what I say is happy, and so then we went right to the center. All right, so let's try another example. So in this practice, I want to do carbon with 4 chlorine. So the first thing I would do, step one, is you arrange them. So since carbon is the first element, I'm going to place it as the central atom. And then I'm going to place 4 chlorine around it. And I like to do it all at 90 degrees. It's just helpful. It's just how I like to do it. But remember, as long as you had carbon in the middle and the other chlorine around it, 4 chlorine around it, you'd be all right. So that would be the first step. And then the second step is to get the valence electrons. So I have carbon and chlorine in this structure. Carbon is in group 4A on the periodic table, so it has 4 valence electrons, and I only have 1 carbon, so that would bring 4 valence electrons. Chlorine it's in group 7A, so it has 7 valence electrons. And be careful, though, here I have 4 chlorine in the structure, so each one brings 7. So that's what, 28? And then I'm going to add these two numbers together. So this one has a lot more electrons to work with, in part because chlorine has a lot of valence electrons. Okay, so those are the first 2 steps. Arrange the atoms and count the valence electrons. Then we need to place the valence electrons onto our structure. So start by drawing single bonds between the center atom and the periphery, which is the outside. Now, when I do this, each single bond represents 2 electrons. So I used, 2, 4, 6, 8. I used 8 electrons by doing the single bonds. So then what is that? 24 electrons are remaining. And you don't have to write that down, but you do want to think about how many electrons you're using. So the 24 remaining get placed onto the structure, so everybody has 8. So I say they're happy, except hydrogen, which I don't have hydrogen here, so I'm not going to worry about it. So then I would take it, and I just start with 1 chlorine. So the chlorine already has 2, so then I would add 3 pairs. Right? So then that chlorine has 8 because it has 2, 4, 6, 8 because I added 3 lone pairs. And all the chlorines are the same, so I'm going to go around and add 3 lone pairs to each chlorine. Now, if I count that up, I gave everybody 8. Let's count how many total. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So see, I used all 24 electrons. So now let me get all the highlighting off so I can look at it a little easier. So now if I count up all the electrons on my structure, I have used 32 electrons. So that's total. But before I say, oh, that's great, look at your central atom, and does it have 8? And it does, 2, 4, 6, 8. So this structure would be complete as it is. This is the correct Lewis structure. So let's again review what I have to be complete or correct. I want to meet 2 things. I used 32 total electrons. So if you count all the electrons present, remembering that each line or single bond is 2 electrons. If you count all present, I use 32. So that's one thing that's correct. The second thing is every atom present has 8 electrons around it. So if you looked at any given atom, like if I looked here, there's 2, 4, 6, 8. So that would have 8. And if I go around, all the chlorine would be that way. And if I go here, there's 2, 4, 6, 8. So everybody has 8. So I've used 32 electrons to give all my atoms 8. So that's what you're trying to do in Lewis structures. Okay, so let's do one more like this, and then we will look at, remember there was a step that said if one of them doesn't have 8, go to step 4. We'll look at what step 4 is. So let's do ammonia, which is NH3. So step one is put them in order. So I'm going to put nitrogen first, in the center, sorry, because it's first. I'm going to put my hydrogens around it. And if you put one of the hydrogen on the top instead of the bottom or the side, all of that is okay. Then before I get going, I have to add up my valence electrons. And so I have nitrogen and hydrogen in this formula. Nitrogen is in group 5A, so it has 5 electrons, and there's one of them. And then hydrogen is in group 1A, so it has 1, but in this particular compound, there's 3 hydrogens, so that's 3 electrons. So now I have 8. So 8 total electrons. So then what I do is I draw single bonds to connect. That uses 6 electrons. And so I have 2 electrons remaining. And for the 2, so any remaining electrons, you have to complete your octets. And normally we look at the ones on the outside. So in this case, that would be looking at the hydrogens. But the hydrogens already have a 2, which is their happy spot. So we're not going to do anything with the hydrogens. And so the remaining 2 will go on the nitrogen. So after you do the outside, any remaining pairs will go on to the center. So if everything on the periphery is satisfied, if you have anything left over, you just put it onto the center. So then to double check, always double check, even this is a simple one, but make sure you used your total. So we did use 2, 4, 6, 8. And then make sure when you look at each element that they are satisfied or happy. So for hydrogens, that would be having single bonds. So all of our hydrogens are satisfied. And for anything other than hydrogen, it would be having 8. So nitrogen has 2, 4, 6, 8 around it. Okay, so that is the basic idea of how you do Lewis structures, except there was that thing that said, if this happens, one more step. So let's look. This is step 4, and I'm going to give you some examples, but let's go over a little bit first. So sometimes when we get to the end and we've added or used all of our valence electrons, we'll notice that the atom in the center does not have 8. And so when it doesn't have 8, and we can't add anymore because we've used all of our valence electrons, what it means is we have a multiple bond. So what we'll do, and here's the plan, and then I'll give you an example. I'll give you 2 examples. It says 1 lone pair of electrons can be converted into 1 bonding pair. So what we're going to do is we're just going to move one of our lone pairs from a periphery atom onto the center. Now, as a reminder, and in the review of Introduction to Covalent Bonding, I went over some of these things, but a double bond is written like 2 lines. Let me get a different color. So this is a double bond right here between the oxygens, and that would represent 4 electrons because each line represents a pair of electrons. And a triple bond looks like 3 lines, like this between the nitrogens. With the 3 lines, it represents 3 pairs, which would be 6 electrons. So let's see how this applies to some examples. All right, so here is a molecular formula, and this has 3 different ones, but we're going to treat it the same way. So steps 1, 2, and 3 that we've been doing is going to be the same. So the first thing I'm going to do is arrange them. Carbon is the first element, so I'm going to put it in the center, and then around it I'm going to put 2 hydrogens and 1 oxygen. And it wouldn't matter if I put the oxygen on the top or like that doesn't matter as long as you have carbon in the middle and around it you have 2 hydrogens and 1 oxygen. And then I'm going to need the valence electrons. That's step 2. So let's see, I have carbons, hydrogens. I'm squeezing it a little, sorry. Carbon is in group 4A, so it has 4 electrons and we only have 1 of them. So carbon brings 4. Hydrogens have 1 electron, valence electron, but there's 2 of them in our formula. I see it over there. So that is 2 electrons. And then oxygen is in group 6A. There's only 1 oxygen in this formula, so that's 6. So we have a total of 12 electrons that we have to place. Okay, so that's step 2. So step 1 is arrange, step 2 is count your valence electrons. Step 3 is place the electrons. So remember in step 3, what we do first is we place single bonds. Now, if I think about it, each single bond is worth 2 electrons, so I placed 6 electrons. So I'll just write it down here for us to see together. So I used 6, which means I have 6 remaining. With the remaining electrons, you complete the octets of the elements. Don't start with the center atom. Okay, so we look at the exterior or periphery atoms. So hydrogen has 2. I'm not going to add anything to that. Hydrogen has 2. I'm not going to add anything to that. Oxygen only has 2. Now, oxygen wants to have 8, so I'm going to add 3 pair here. Okay, and I'm going to rewrite this over here so I can keep going. So when I added 6 to this oxygen down here, when I added 6 there, I used all the electrons. Let's just count. I've used 2, 4, 6, 8, 10, 12. And I only had 12 available. Okay, so I've used all 12 electrons. So I cannot place anymore. But now when I go and look at my center atom, carbon, it only has 6 electrons. 2, 4, 6. Now I can't just add a lone pair because that would use 14 electrons. So this is what step 4 says. Let's read it again. We'll take 1 lone pair up here and convert it to a multiple bond. So I'm going to take 1 of them from oxygen. I'll just take this one. It wouldn't matter. And I am going to redraw it as a double bond. So I'm going to take it from an unshared pair to a shared pair. So let's see, it would be like this. Like this. So now what's happened is I still have only used 12 electrons. We can count. We can go 2, 4, 6, 8, 10, 12. So I've only used 12 electrons. But what now is true, by making the multiple bond, carbon sees 8, 2, 4, 6, 8. And oxygen sees 8, 2, 4, 6, 8. So oxygen did not care that I moved over here the electron pair because oxygen still sees it as part of its 8. But what it did was it solved the problem that carbon only had 6. So if you get to step 3 and you've placed all of the electrons and your central atom does not have 8, that will indicate to you that you need to make a multiple bond by moving one of the electrons from the exterior one to a shared pair. So I want to try one more example of that, and then I have one other thing to show you. So let's just try one more example here. Let's do HCN. Okay, so hydrogen can't be in the middle, so then just go to the next one. So I'm going to put carbon in the middle, and then that means hydrogen and nitrogen are around it. So this is a situation where the formula actually looks like I had both, like the formula and the structure look the same, like they're in the same order, okay? And then we're going to add up the valence electrons. So hydrogen, carbons, and nitrogens. Hydrogen has 1 valence electron, and there's only one of them, so that's 1 electron. Carbon has 4 electrons, and there's 1 of them, so that's 4 electrons. And nitrogen has 5 electrons, and there's 1 of them, so that's 5 electrons. So when I add these all up, I get 10 electrons. That's what I have to use. So now I'm going to write single bonds. So what did I use? 4 electrons, because each one. So now I have 6 remaining. And remember, with the remaining electrons, we fill the outside octets. So looking back at the structure, hydrogen is complete, like it has a double bond. But then looking at the nitrogen here, it needs 3 pairs, right? Because it only has 2. So I'm going to add 3 pairs. So that's 1, 2, 3. Now, if I count up my electrons, I've used 2, 4, 6, 8, 10. So I've used all 10 electrons. I have no more electrons to place on my structure. But I have not thought about the center. I only thought about the nitrogen. So I look at the central atom and I see that it's not happy. It has only 4 electrons around it. But I have no more to add. I cannot add lone pairs. So in this situation, I'm going to take a lone pair off nitrogen and I'm going to redraw it onto I'm going to redraw it as a shared pair. So I'm going to take off this one and I will erase it in just a second. And I'm going to redraw it here. Okay. Now, if I look at carbon, it got better. Now carbon has 2, 4, 6, still doesn't have 8. And nitrogen is still happy because it has 2, 4, 6, 8. Okay. So to fix carbon, I have to do this again. So this one would require a triple bond. So I'm going to take another one off nitrogen, and I'm going to draw a triple bond. Now looking, carbon does have 8. 2, 4, 6, 8. And nitrogen still has 8. 2, 4, 6, 8. Because these, my eraser's a little too large, so it took pieces off my N. So those are gone because I moved those to the shared pair. And just to double check, we didn't add any extra. We have 2, 4, 6, 8, 10. So we didn't add any electrons, we just moved them. All right, so I'm going to show you one more example, and then you'll be able to practice at homework. I think I have some other just practice lesson videos that you can see maybe some other examples. Some of these I probably did as well because I usually use the same examples in instruction. So, there's something called a resonance structure, and resonance structures are when you can have more than one correct Lewis structure for a particular compound. And at some point, if you take more chemistry, you may have to draw all the possible resonance structures for something. But for us, I'm not going to have you do that. I just need you to know that there could be more than one correct Lewis structure. And I also wanted to teach you, as in this example, about what happens when we have an ion. So see that 2 negative right there? What happens then? So we're going to do a Lewis structure for our example, CO3, 2 negative. And don't be worried, it's okay. All right, so I would put carbon in the middle and then 3 oxygen around it. And then I need to add up the valence electrons. So I have carbons and oxygens. Oops, I don't want to put that there, sorry. Carbon is in 4A, so 4, there's only 1 carbon. And oxygen has 6 electrons. It's in 6A, but there are 3 of them. So add all of those in, so that's 18. So what is 18 plus 4? That's a total of 22 electrons. Now, what I did not account for was the -2 charge. So recall when we were talking about ions is that negative charge arises because electrons have been gained. And so this is what we call a polyatomic ion. And for this polyatomic ion to be stable, it actually gains 2 electrons. So this is what that means for us in Lewis structures. Because it's gaining 2 electrons, we have to add 2 to our total. So our total is actually not 22, but 24 electrons. If it were a positive charges arise from losing electrons. So in that situation, you would subtract an electron from your total. Now, once you've done that, this is the only real difference from drawing Lewis structures of ions, polyatomic ions. So now everything should be at least familiar. So we got 24 electrons. We're going to draw single bonds. So 3 single bonds, that means I've used 6. So I have 18 electrons left. To do the 18, we're going to first look at the periphery atoms, in this case oxygen. So if an atom has a single bond and it needs 8, it's going to need 3 lone pairs. So I'm going to go around and add each oxygen with 3 lone pairs to each oxygen. And by doing that, if you count how many lone pairs I've added, I added 18 electrons. So I'm going to go around and count, but by my estimation, I've added all 24 electrons. So let's just count 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. All right, so I've added all the possible electrons. I have satisfied the periphery, but I did not look or do anything to the central atom. So I come back and check, and I see that the central atom only has 6 electrons. So if you've added all the electrons and you go and check your central atom and it has less than 8, that means that you will need to create a multiple bond by moving one of the lone pairs on a periphery atom to a shared pair. Now here's where resonance for this structure comes in. You have 3 equal oxygens, and I could take a lone pair from any of the 3. In this situation, it would all be an equal structure, but it might look different in drawing because I might choose the left side oxygen and you might choose the right side. Both would still be correct and representing one of the resonance structures. So I am going to choose the left side, so I am going to erase the top lone pair here. Oh, like I told you, my eraser's too thick. I'm going to erase that lone pair, and I'm going to not get rid of it, but redraw it as a double bond. So now, looking at my carbon, it now has 8 electrons around it. And again, just by shifting that lone pair to a shared pair, that oxygen is okay. And I could have done this to any of the oxygens. That's what it means to have a resonance. This one has 3 resonance structures. Now, one thing they also often do for polyatomic ions is they draw big brackets around the structure and put the charge outside of it. That indicates to someone looking at your structure that to draw it, you have added 2 electrons. So it's better representing what you've done. So again, resonance structures are just like drawing any other Lewis structure. It's just when there's a possibility of more than one structure. Sometimes they're equal, like this case. There's other times when they're not equal in likelihood for resonance structures. In our class, I will accept any correct resonance structure as the Lewis structure. And then the other thing I just want to remind you as we finish up, and you can go and practice, is when you have a charge, if it's a negative charge, add that number of electrons to the total. If it's a positive charge, subtract that number of electrons from the total. All right, so in the next couple of videos, we'll learn what we can use Lewis structures to help us understand better.